Okay, with this question it says prove algebraically that the straight line with this equation is a tangent to the circle. Now if I just mention briefly, when it says the word tangent, tangent is a line that just touches a circle in one point. So we're basically trying to find out where this line intersects this curve, and there should only be one point, but we're going to solve it the normal way. It's basically a non-linear simultaneous equation question. So when we do non-linear simultaneous equation questions, when we've done it in class, we've often made y the subject. So we've said make y the subject and then sub it into the non-linear one. In this case, if I make y the subject, and then I divided through by 2, I'd end up with a half x, which means when I sub it into this, it's actually going to make it a little bit more complicated. So this is one of those situations where, instead of doing that, let's make x the subject of this. So if I just take the minus 2y across, so add 2y to both sides effectively, and it looks like that. And then I can sub this into the nonlinear, which is this one up here. So I've got x squared. Now instead of x squared, I'm now going to substitute in 2y plus 10 instead of x. So x squared plus y squared is equal to 20. So if I expand these brackets, 4y squared plus 40y plus 100 plus y squared equals 20. So I'm going to keep going with this. Now when you've got simultaneous equations where you're trying to, it's simultaneous if you're trying to find out where two things intersect, which is what we're basically doing here. If you're trying to find out where a curve and a line meet or where they intersect, you are doing simultaneous equations. We've said in class that with nonlinear simultaneous equations, when you've got a linear equation and a nonlinear equation, you are very, very often, the vast majority of the time, you're going to end